In this video, we are going to explore methods of representing spatial relationships and form in foam. We will cover the following foam modelling techniques: sourcing, breaking a model into multiple parts, cutting, adhering, carving and shaping, finishing, coating and protecting, and painting. The model we are creating today is based upon Andrea Morgante's dissected architecture installation. The installation investigates the possibility of creating living environments that, rather than being built by parts, are actually created by hollow spaces carved from solid mass. The dissections are a visual act that clinically expose the fragile yet powerful dialogue created by two opposite states, solid and void, rigid and soft. XPS foam is an excellent choice for creating complex 3D forms, as it is significantly easier and quicker to carve than timber, and unlike 3D printing or casting, it doesn't rely on having a finalized design. Foam allows for haptic exploration of a design idea through carving and shaping the curves to suit your design intent. Foam can be used to produce concept models that showcase form, as well as refined presentation models. The advantages of XPS foam is that it is cheap, non-toxic, and can often be sourced for free by utilising the foam offcuts in the workshop. When modelling a form with a substantial amount of negative space within a larger mass, it is difficult and time-consuming to remove the material from within the foam stock. A better way to achieve this is to break the whole model into a series of sections that can be shaped and adhered together later. After determining the scale of the model, the foam is cut into appropriately sized sections on the bandsaw. Now that a series of equal foam blocks have been cut, the profiles are marked out showcasing the area to be removed. If precision is required, a digital model can be used to generate sections to ensure cuts are accurate. However, as the intention of this model is to explore the form through making, rough approximate cuts will be sufficient. The roughly cut sections are fixed together with PVA glue. Typically, massing models would have all pieces fixed together. However, as the model is hollow, it is better to leave the pieces in two or more parts, as it will provide better access to shape the internal areas. Rasps are used to begin shaping the roughly cut segments. A rasp is a rough tool used for coarsely shaping timber or other materials. Take care when shaping with a rasp, as it grates through material and can easily tear foam, which can result in damage to the model and injury to the modeler. Once the foam has been coarsely formed with a rasp, a file can be used to smooth and articulate certain elements in the model. Files are less coarse than rasps and can be used for finer work. Foam is easily worked and is an excellent material for exploring free-form design. Now that the segments are roughly formed, they are fixed together with PVA glue. Adhering the segments allows for the model to be shaped as a single entity, ensuring the connections between the multiple pieces are smooth and consistent. Certain glues and paints can eat away at XPS foam. PVA is selected as it adheres to foam easily and is cheap to use. Polyurethane glues can also be used to bond foam. Check with workshop staff about which glue is best for particular applications. Always do a test of any glue or paint on a scrap piece of foam to make sure the foam doesn't react to the chemicals. Sandpaper and smoother files can be used for delicately shaping the foam into a cohesive, undulating form. Working with fine carving tools allows the modeler to meticulously shape the foam. Unlike the rough shaping processes that set out the initial form, this finer work is much slower and relies on a constant interplay between the eyes, hand and mind. An advantage of foam is that any gaps can be filled to give the appearance of a smooth surface. A standard water-based filler is used to fill any small imperfections. For larger or more detailed gaps, consult workshop staff on the most appropriate filler to use. PVA glue can be used to apply a protective coating to pieces of foam. This allows finishes that would typically dissolve foam to be used, as PVA acts as a barrier between the solvent and the foam. The model is given several coats of PVA glue to create a protective seal around so that spray paint can be used to finish the model. If applied directly to the surface, the chemicals in spray paint would dissolve the surface of the foam. The model is given a light sand with a fine grit sandpaper to smooth out any inconsistencies during the coating process. Care is taken not to remove too much of the protective coating. Spray paint can contain volatile organic compounds which can be dangerous if inhaled. Only use spray paint in a well-ventilated area. The workshop spray room is fitted with an extraction system that removes harmful chemicals. Check with a workshop staff member if it is your first time using the spray booth. The spray booth is fitted with spray guns that can be used to achieve a high-quality finish. As this model is only being used as a tool or showcasing an idea and not as a presentation model, a can of spray paint will suffice. Apply even, consistent coats of spray paint and consult the back of the can to determine the appropriate time between coats. Foam is a great material for exploring complex volumes. The ability to oscillate between rough and fine carving tools means you can express forms relatively quickly. Typically, students will look to digitally model complex organic forms. However, working digitally can lead to a reduced appreciation of the way a form comes together, whereas working with physical models creates an acute appreciation for the nuances of the form. The ability to hold a model and constantly examine and assess the design as it unfolds develops a greater understanding of the final form. Each decision can be linked to a physical act that shaped the final outcome.